Well, while people are thinking about their questions, I will ask the first question to Jose and to Danielle. But what are the technical barriers to fully realizing personalized or precision nutrition?
Technical barriers. The technical barriers for precision nutrition is that we have not studied enough people, not enough depth. Obviously, everything that we have presented here about artificial intelligence is in our minds more than in the publications, very few publications. And we have to convince ourselves as scientists that we can have information about all the omics that we can measure. But as demonstrated in some of our studies and in many other studies, the environment of the individual, it happens also at real time, and it changes during the day. That's why precision chrononutrition should also be part of the game. Is also important for our response. Measuring, for example, how you slept, or when you slept the previous night, defines your responses, glucose responses, the following morning. So we have to be really 360 degrees and measure everything that we can.
So Danielle, do you have anything to add to that?
Sure. Can you hear me okay?
Perfectly.
Great. Yeah, so what Dr. Ordovas said is absolutely correct. We just don't have enough data. One way to think about it is like a lot of the legacy data, as he mentioned, it's doesn't cover, that the sample size isn't very large. To put it into perspective, if you were thinking, well, first there's the limitation that any nutritional epidemiology, you're limited by what people are already eating. And it could be that optimal health won't be achieved what anybody is already eating. So that's the first problem. And then the second problem is that the search space is enormous. Like, let's pretend for a moment you don't care about the person's physiological state at the moment. You don't care about the dose or the timing. And we, of course, care about all those things. But just to reduce the complexity, let's say all those things are fixed. Even if you wanted to, think about all the different ingredients that Americans consume, there's, thousands and thousands of foods, but reduce those down to about 1,000 core ingredients. If you were going to test a combination of just 10 different ingredients every day, that's combinatorial math. 1,000 ingredients, choose 10. It's like quintillions of years. So quintillions of human lives. Like we literally cannot test everything. But I've tried to give the scope of like just how enormous the search space is. And we have like just a few dots within there where we have data. So we're going to need to be very strategic about what we test, and that's why we have nutrition science.
Yep. Amanda wants to add, and then I'm seeing lots of questions in the audience. So.
Yeah, just because this was touched on in that workshop that I was talking about at the National Academies, and we had a wonderful presentation by Nick Shore, and what he was talking about was, these N of 1 studies that you have with small sample sets, but rich data sets. So you measure everything all the time in these 30 individuals, and then you can take the existing data, the data, I don't want to call them data poor, but like data poor sets from cohort studies. And then through the integration of those heavy data sets versus the data poor, start getting at those populations that are different responses. Personalized, but definitely. I don't know how to do any of that, but it sounds good.
we have done some N of 1 studies, and they are so time-consuming and intensive on both sides that despite the benefits, they are clear, and Nick has shown those benefits over and over. They are not taking up, and it's because first the statistics are not the classical statistics when you are dealing with them. The only way that you get to the classical statistic is by pulling N of 1, and then you go back to almost the average that I was mentioning before. But yeah, the digital twins, when we get that better, and the N of 1 will be probably the final answer to our objective.
Okay, so I see a question over there.
My question was about the comments around food safety database and using social media to help identify food safety issues. Are you concerned about, or how are you preventing people from effectively swatting food safety stuff by leveraging the mining of social media to identify issues that may or may not exist? So advocacy groups putting in false reports through social media on things that you then have to follow up on and potentially take resources away from real issues.
That's a really good question. So when we started doing this, one of the reasons why we stayed away from social media was exactly that, right? There was so much noise in there that it's difficult to ascertain which ones are real and which ones are just people. And sometimes you can even pick up jokes that look like signals, right? So those are some of our major concerns, which is why we stayed with the scientific literature. So the original signal detection only looks at those major news articles, scientific literature, and tries to back them up with that, right? Now, going to the using the social media now, it's not the main source anymore, right? It's just an additional input for what we need to be concerned about. But we are working with one of our internal organizations that receives data from CDC to look at, okay, what kind of actual reports are you getting? And can we correlate that with what we're getting with social media so we can find ways to be more strategic about what we follow up and what we use from that session.
It also can be valuable.
Yes. Right, yeah.
Great. Craig Llewellyn from Exponent. Question mainly focused for Danielle and Ernest, but others please drop in. We know the value of NHANES in terms of understanding intake. And just wondering from Danielle, from your perspective, the ability of the tools that you were talking about to help us refine NHANES in terms of recipe and understanding from whole foods or complex foods and getting to those aspects of intake. And that follows over to Ernest in terms of the same way. Does Wiley bring into NHANES data into its evaluation to understand intake of from a foods perspective, a recipes perspective, down into that level of detail? Thanks.
Yeah, so are you asking me about how we use NHANES data, or whether what we're doing informs the NHANES process?
Really, how the work that you're doing works in concert or to enhance the NHANES process, using the tools to refine it in a way that gives us more better information.
Danielle, were you able to hear that?
I have closed captioning on. Thanks for asking. So far we have been analyzing NHANES data, and I haven't really thought about the other way around, where we use what we learn to provide feedback to the NHANES process. But I love that idea. I'll be thinking more about that. I will say, from what we've learned from analyzing NHANES data is, a few things. One being that when we disaggregate all the mixed dishes down to ingredient levels, we have a lot more success with finding signal in the noise, so to speak, because there are a lot fewer ingredients than there are all kinds of infinitely complex types of mixed dishes. And so that's a way of doing like data dimensionality reduction in a way that's lossless and very much informed by a priori knowledge. So I mean, so we're making some progress with using NHANES, but we also find things where we really wish something was done differently or some things are measured that aren't. So I love the idea of using this as a feedback loop. So yeah, let me know who to contact. Thank you for the question.
So Ernst, did you want to add anything to the part that was directed at you?
Sure, yeah. So we have pulled in the enhanced data. We've used it more as a relative exposure. So we've graded it from the more specific and we kind of like combine it through a process to get to the more general. So if we find a product, we look at the more specific first, right? And if we don't find it there, we go to the, okay, if we generalize this, what will be the next stage? But we've used it more as a relative exposure measure. So basically, the thinking is if you have milk and you have rice and they're both contaminated, which one of those are consumed more, right? So it's relative. It's more than not an exact, like, you know, when you do an exposure analysis where you do a proper exposure analysis, but we use it to scale up the signal. So if you really think milk is consumed more, then the milk gets scaled up based on the metric from the enhanced data set.
So this was really an outstanding session. I enjoyed it very much. I have questions for all of you, basically. Jose, it seemed to me like what you were saying that was absolutely necessary to be able to pool cohort data and whatnot is a common lexicon and label of categories. Is there any work underway to make a standardized alphabet for how to characterize cohort studies? If not, who could do that? Because that's a manageable thing.
Well, and that's why I showed that third slide about the NIH solicitations, and it's precisely to bring a study. We know that we need power, and so even the UK Biobank may not have enough to answer many of the questions that we have.
But that's different than getting the standardized lexicon so that multiple cohorts can be pooled.
Yeah, that's what I mean. The idea is to develop standards.
So NIH is doing that.
Yes.
Oh.
Well, NIH is giving funding
people
in order to precisely harmonize those
and so the
those
timeline
studies.
on that is within 5 years.
That's like you were mentioning what it takes to do a good review, to do a good harmonization of some of these legacy studies that go back to from 47, right? If we want to do a good job, 5 years, either AI help us from different angles or by human, it will take probably more than 5 years to achieve that holy grail of being able to draw from
But
all
you're
the different studies and experimental conditions and so on.
So Amanda, to shift gears, you were talking about all the efficiencies that are coming along with digital access for authors. I'm here to cry for editors and reviewers. We're about saturated with the systematic reviews coming in to review journals. We can't get reviewers anymore. It scares the pants off me to think there might be more of them coming faster.
As an editor as well at a journal, I feel your pain, and I think we're all aware of like there are systematic review farms in different jurisdictions and they're producing them, and so you still need the subject matter expertise, because I look at a lot of systematic reviews coming out of different groups and they have not applied even standard methodology, let alone have produced things that are facilitated by AI. And so we are going to have to be.
Could we develop a robot approach to, screening and trashing those?
I'm
So that it
sure
doesn't
that-
have to go to human reviewers?
Yeah, no, I'm sure that we could, because I mean, right now, there are tools out there to say, was this generated by an AI algorithm? Was it generated by ChatGPT? So I could foresee that there should be tools out there that can do those kinds of analyses and help you with that. But are we there yet?
We're ready for that.
Well, one of the simple tools is, are the authors familiar with the topic? Because there are places they have become farms of reviews, and they don't have any subject matter experts, but they keep cranking reviews that they are this level.
So Ernest, a little tongue in cheek, did Wiley predict we're going to have a tank in exports and imports with tariffs?
Trying to get me fired?
I think we should put tariffs on those systematic review parts.
Yep. So Johanna?
Thank you. A wonderful panel. One question for Jose, and that is one of the constraints that you mentioned many constraints, but one you didn't mention was the proprietary nature of a lot of these cohort data. Even though most of them are funded largely from government, there's still, the investigators still aren't going to just throw them into a pool, regardless of what a NOCI says or doesn't say. So I wondered about that, wondered how we could get over that barrier for getting a bigger database.
Obviously that is a barrier. It was written in one of my lines that I have to speed up. That's why we need also legal teams as part of this process, because the informed consent, we start with the informed consent. Many cases, most cases, you cannot re-consent. You can just de-identify the data, right? But then are the IPs and the intellectual properties that nowadays an exchange of data could take between one university and another, could take 1 year until everything is smooth and so on. If you multiply that for the number of studies that have to be included, it cannot be done unless we change the way that we move forward when it comes to that sharing, right? We have to become more imaginative and abandon some of the classical ways to do it without obviously breaking any ethics.
We have a question back there.
Thanks, everyone, for a great panel. My question is also for Jose. Really following up a little bit in terms of data quality and structure. I thought in one of your comments that you said briefly, which struck me as very interesting, was that you're using epidemiological data. It actually gave you a better predictive model of outcomes than using multi-omic data. Did I hear that correctly?
Well,
and is that based off of, if that is correct, is it based off of the size of the data set? Is it based off the structure of the data set? Or is it actually more reflective on the omic side that we still have a lot to learn?
You have enough experience to know the answer. That is, it is a little bit of everything. The data that I was referring, it was the predictive study by Soy, that when we went over which components were more important, predict the variation on response, you have, again, depending on the if it's triglycerides, glucose, whatever, it's quite different. But things like genetics, for example, for triglycerides, you don't have any meaning. Microbiome was there in the middle of the territory, giving value to everything. But for example, when you eat, or how you eat, and things like that, for some of the outputs, it was had more impact on predicting variability than it was. However, the dip doesn't have methylation. And in our hands, methylation is very relevant as a predictor of response and as a predictor of future disease.
So I'm going to take the chair's prerogative and ask the last question. And this is to all of you. We've heard a lot about the potential benefits that we could get from artificial intelligence. But what are the potential risks using generative AI besides the garbage in, garbage out? Are there other risks that we aren't thinking about that should also be considered? And I'll leave that to everyone to potentially answer.
So far, one of the problems that we have, and is related to some of the questions, is that the people that are really experts in AI, they keep calling a black box. And we don't know what is doing that black box, right? So that goes against the transparency that we are all looking in when we move from point A to point B. So to me, obviously, those that are developing for commercial purposes, they don't want to open the black box, right? And understand or communicate what is really going. So I am afraid that even though you call it artificial intelligence, there is still going to be bias.
So
Related to that, I think.
Let's let Danielle go.
Oh, sorry.
Yeah, it's probably good to follow since we're on the same topic here. I agree with Jose that bias is a problem, especially the way we're using historical data, and we know that there's many people that haven't historically been included in these trials, so we miss out on some important phenotypes in our population. But I fear unintended consequences. And one of those unintended consequences would be that we are thinking we don't have personally identifiable data when in fact we do. Where a lot of times, like these omics, they could really be fingerprints of individuals. And certainly literal fingerprints we think of as personally identifiable. There's no reason these other omics data sets wouldn't also be in some way, form, or another. And especially as you bring together a lot of data and aggregate, the chance that you can identify an individual goes higher and higher with the amount of data. So those are the sorts of things that privacy and that sort of thing bothers me, keeps me up at night. So thanks for the question.
Amanda, sorry to cut you off.
No, that's totally fine. I think for me, reproducibility is an issue, and I think that relates back to the black box issue, but also validation. I mean, if the gold standard is a human goes in to validate the work that was done, are we really getting the time savings and the costs that we need? But without it being validated, how much certainty and trust do you have in outcomes? And so I worry about making decisions based on data that's not necessary.
I think I echo a lot of what you just said. I think those are the risks we see. So, by your story about ChatGPT lying to you, we had a similar thing. We started building the base model for a while. It uses the Lemay 3.2 open source library as a space model. And before we put enough guardrails in, one of our folks over in that supplements was asking a question about, can we ask it about the status of a particular substance, right? See if it can do, sort of like if you had a reviewer, what would you say? So we did like a bunch of prompts to give it a little bit of background to see if it would do it. It came up with a really good narrative about this particular substance, cited a series of articles, properly formatted. And I'm a neuroscientist by training. I don't know enough about dietary supplements to know whether that was correct or not. So I asked one of the reviewers, does that look right? He's looking at it, he goes, I don't know. So we do another thing, right? Let's ask it where it found that information. We ask it and it goes, oh, I'm really sorry. As a regulator of the Food and Drug Administration, I should provide you with accurate information. I made that one up. So he just lied to our face. So as regulators, we were horrified, right? But as scientists, we were also very intrigued because it was so well done. The formatting was really, really correct. I mean, there is no other way you would know that it was incorrect if you don't know the field, right? So validation becomes a major issue. If you just deploy it in there, a lot of people would take its word as gold, and it isn't. So, I mean, what we did was we went around, we were interested. We were like, okay, how did we find this? We looked at the authors' names. We found the authors were real authors, right? On different subjects. We found the article title was snippets of different articles that he had joined together to make sense. And he had an abstract that he wrote that I'm not sure where he found that one from. But it used something that was really believable. That if you don't know the subject area, you say, yes, it's true. So validation becomes a major issue, and then that you transform the time savings. So how do you control for this so you don't completely get really bad data?
Well, unfortunately, we're going to have to end this session, but please join me in showing appreciation for all the speakers.